Hello, guys. Welcome to Cheenta School of Statistics and Data Science.
Here we have a infinite series, summation n from 1 to infinity, n to the power alpha plus 1 by n to the power 3 alpha plus 2. So and we have to check the condition for convergence of the series based on the values of alpha. So whenever we see a series like this, we know that it's a bit difficult to apply the usual ratio test or root test. I'm not saying it can't be applied, but it's so difficult to apply since there's powers of alpha in both numerator and denominator. And
Can we apply
since we don't know
Wester's
the
M
values,
test?
yeah,
Can we apply Wester's M test here?
Wester's M test. I think you can, but in general, when there's powers of alpha in both the numerator and the denominator, I usually prefer personally, it's the limit comparison test because
So
we have to find a range
if
for
we
alpha.
if we divide upper and lower part with n to the power alpha, then it must. To set it up in the form of a Wester's M test. So that gives me alpha greater than half.
Mm, True, but before that, you need to check whether they are bounded or not, right? So you need to do whether this term is bounded or not, and you need to obtain an upper bound mn, and then you need to check the convergence of this thing. So what I think that when you are going for a competitive exam, you don't really have much time to figure out all those things. So in those cases, sticking to the basics tests usually is the better option. Obviously, there are certain problems which demand the use of a Wester's M test, but for this problem, I have gone with a simpler one, that is a limit comparison test.
We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI Mstat, and CMI MSc Data Science. Let's enjoy the rest of the video. Stay tuned and stay blessed.
An, which is this thing, n to the power alpha plus 1 by n to the power 3 alpha plus 2. And applying limit comparison test with Bn is equal to 1 by n to the power 2 alpha. I've chosen this particular thing so that we can get a finite limit of an by bn, since you can observe that if we multiply this thing with n to the power 3 alpha, then we can potentially simplify a lot. So limit n tend to infinity an by bn, which is this thing divided by 1 by n to the power 2 alpha. So n to the power 2 alpha is basically multiplied with the numerator, and we get n to the power 2 alpha plus n to the power 3 alpha plus 2 alpha by n to the power 3 alpha plus 2.
Okay, here I
And
have a question.
yeah.
So that is when you are choosing Bn, and you are choosing Bn as 1 by n to the power 2 alpha, and in the and an is given in an we see n to the power alpha in numerator, and n to the power 3 alpha is denominator. So Bn
Yeah.
is equal to n to, you are choosing Bn n to the power 2 alpha on what basis?
Because
why not n to the power 3 alpha itself?
yes, see, when we have this n by bn, we basically obtain this form, is n to the power 3 alpha plus n to the power 2 alpha by n to the power 3 alpha plus 2. This form we have, and
Yeah.
this and limit, and if we divide the numerator and denominator by n to the power 3 alpha, we get a finite limit of this thing of n by bn. So
Okay, so
if bn
for
converges,
sake of the finite limit, we are designing it in this way.
exactly, it's a technique. Like when the powers are like this, you choose something such that the leading powers in the numerator and denominator are equal. Like for example, if you have chosen n to the power 3 alpha here, you couldn't have concluded anything because the numerator would have gone to a higher power. So you couldn't have concluded because the limit wouldn't have been finite and you couldn't have concluded anything.
Okay, I got it. And one more question. That is,
Hmm.
we are getting the convergence, but is it absolute convergence?
Absolute convergence of this series.
Yeah. I I am asking
Yeah.
because the my actual question was,
Yeah, but
if
this
we if
thing,
we
this series is positive, right?
hmm,
So the convergence and absolute convergence is the same thing. It's not an alternating series.
okay,
If it would have been
because
an alternating series, then then that thing would have raised up. But this is a positive series, so the terms are basically equal to the absolute values of this thing.
all right.
Okay, so
So
that's basically the
mhm,
same thing. Yeah.
sure.
So the limit n tend into infinity an by bn, that comes out to be 1. So, and therefore an and bn converge and diverge together. And we have bn is equal to 1 by 2 to n to the power 2 alpha. And using p-test, we know that this converges if and only if 2 alpha is greater than 1. That is, in p-test, we have 1 by n to the power p, and that converges if and only if p is greater than 1. So, this converges if and only if 2 alpha is greater than 1, which means alpha is greater than half. So, C is the correct option. So, let me move to the last problem of today. So, here we have a given 4 cross 4 matrix, and we have to compute the determinant of this thing. Now, obviously, we can use the brute force method of just just expanding along a particular row, but obviously, we will not do that here because for large matrices like this, it's usually difficult to go by the row expansion method. And you can observe one thing here, that this matrix is very close to being an upper triangular or lower triangular matrix. Like you can very easily reduce this to a upper or lower triangular matrix using some row operations or column operations, your choice. I've used some row
Uh,
operations here.
one question, that is,
Yes.
uh, so could you go to the matrix once again?
Yeah.
So if we make it, if we if we turn it into some row reduced echelon form and then find the
Yes.
determinant, will it give the same result?
Obviously,
Okay.
you can turn any matrix to a row reduced echelon form, and the determinant of that matrix will be the same as the original matrix. But we don't need a row reduced echelon form here. We just need to reduce this to a upper triangular or lower triangular matrix. Then we can just take the product of the diagonal elements, and that will be the determinant. Because row
Yeah.
operations or column operations do not change the determinant of matrix. Let me show the solution. I've denoted this matrix as A, and I've reduced it to a upper triangular matrix. So for the first row operation is R4 is R4 minus 4 R1. So the first three rows keep the same. And here this 4 is substituted by 4 minus 4. So that becomes 0. The second and third elements remain 0. And the fourth element is 1 minus 4 into 3, which is minus 11. And next we perform this operation. R3 is R3 minus 4 R2. The first, second, and fourth rows remain the same. And in the third row, this remains 0. This becomes 4 minus 4 into 1, which is 0. This is 1 minus 3 into 4, which is minus 11. And this is 0. So now we have a upper triangular matrix, which we call B. And we know it's a property of upper triangular matrices that its determinant is equal to the product of the diagonal elements. And we can observe the diagonal elements of this matrix is 1, 1, minus 11, and minus 11. So simply multiply the determinant of multiply diagonal elements to obtain a determinant of B, which is equal to 121. And therefore, determinant of A is 121 and D is the correct option.
We give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISI Mstat, and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists.